Okay, so we're going to do the next video here. Here we go. Let's get the drawing stuff ready. Okay, now we move this thing down. All right, now we can put the header there, which is M108 exam 3 review. This is E. Okay, problem number 1 I need to show you is a situation with the Venn diagram as follows. The Venn diagram, let's make it simple. A, B, and C. Okay. Let's say you have in there a point 1, a point 2. You've got a point 3 in here. In other words, not a point. I meant that these are just points, just representing the numbers. They're not a point. So this is a 4 representing 4. That dot represents 4. There's a dot representing 8 and 9 here. Each one has its own dot. There's a dot representing 7, and there's a dot representing 5 and 6. And you're asked not first to tell us about something that's not in A, but, and but is a replacement for and, in B or C. Okay, what should you write? Answer for that is B is to simply write not in A is this, but means and, so not in A, I'm sorry, I forgot the word, the set A there, not in A, so A prime, not in A, and it's also in B or C. That's the way to write that. There's the answer to that. Now, what about it coming at you raw? They're asking you for roster form, right? We've talked about roster form already a couple of times. That means you would pick this that you want to fill in brackets. You want to put them in brackets. So here's what you'd put in brackets. You would put 5, 6, 7, 8, and 9. Because you don't want anything in A, but you do want the rest, 5, 6, 7, 8, or 9. And that's what you would put into roster form. Okay, there's one thing I need on this video. Let's go to another thing on this video that should be there. Let's talk about something from the past, which would be if you would get the probability of a black card. Well, yeah, black card, that's good enough. Black card. That would be question A. Probability of a face card. Question B. Question C. Probability of black card or face card. This one is, you do, I don't plan on reducing. You can do the reducing and you put it into decimal if you need to. Black card would be 26 out of 52. Half the cards are black. Face card, there's 3 of each of the sets, right? The 3 of spades, 3 of diamonds, hearts, clubs. So there's a total of 12 out of 52. Because what's a face card? Jack, queen, or king. Okay, now what about both? I mean, or if one or the other. Well, that would be 26 over 52 are all the black cards. But now, or a face card. You can't count the face cards that are black. You can only count the face cards that are not black. There's only 6 of those, right? The red ones, 6, 3 and 3. 6 over 52. So the final answer is 32 over 52. The formula, if you want to go through the formal formula, and it's on a video in the past, you would do the black cards, plus you would do 12 over 52 for all the face cards, and then you would do minus B and face card, which are both black and face card, would be 6 out of 52. You'd get the same exact result. So you do this. Don't forget to reduce, right? It would be divide by 4, so you'd get 8 over 13. And don't forget to reduce, and maybe they want decimal. maybe they'll want a decimal, so you divide the denominator into the numerator. Okay, that's all I want to say about problem number 2. Now, to get some more stuff onto this video, do not forget, if you have a variance question, and Steve, you're asked for variance and standard deviation. You have to go back to video number 20. Go see video 20. That'll tell you what to do for this. Video 20. However, I also want to tell you, remind you that, let's say, by example, for example, you get a variance of 16.2. What's the standard deviation? And you'll use a calculator. You would take the square root of 16.2. That's the standard deviation. It's going to be the square root of whatever the variance is. That's all I wanted to tell you about, to add to video 20, to remind you from video 20. It's all there. Video 20 and those two things. Okay, I've got some more room. Here we go. Pull up the paper. And I go to my fourth point. Fourth point right here. How about if you have a strange looking thing like this, and it's going to be surprisingly easy, don't get nervous. It's a strange contraption where this is A, this is B. B is another piece of this. Here's B. And the rest of it going over here is going to be C. Right? This is not proportional. I don't do good diagrams, but here's basically what it says. The numbers you have over here are going to say, here's 1, here's 2, not proportional. I cannot do a good job with the proportional. Here's 3, here's 4, right over here. Here's 5, here's 6, here's 7, and here's 8. Right? Not proportional. They'll do much better. Now let's say they tell you that A is worth 0.3, B is worth 0.4, C is worth 0.3. It all adds up to 1. 3, 4, and 3 is 1. It all adds up to 1. So it's all one thing. Here's the question. What's the probability in a situation like this? Here's the question. What's the probability of 1 to 4? 1 to 4, here's the numbers. These are the numbers on the bottom line here on the x-axis. On the x-axis, what's the probability of 1 to 4 having been picked? What's the answer? Here's the answer. 1 to 4? Okay. This goes from here to here. What is that? Answer, that's A plus B. What's A plus B? 0.3 plus 0.4. What's 0.3 plus 4? Where did I get that from? Right over here, from this chart here. What's 0.3 plus 0.4? 0.7. That's your answer. Problem over. Okay, so it looks like a hard problem, not a hard problem. Okay, that ends this video.